Alright, so when they named that gas lab, we actually saw what gas, and we identified what gas will put out a flame. So that was carbon dioxide, which we got the same way. Baking soda plus vinegar gives you carbon dioxide. So carbon dioxide is made out of a carbon and an oxygen and an oxygen. Okay? Most of the air is made out of nitrogen. It's two of those stuck together. So if we looked at that, we could look on the periodic table, and there's a nice little number underneath with some decimals, and that is what, that's called the molar mass. So if you had 1 mole, which is a big giant number of them, it would weigh, for nitrogen, it would weigh 14 grams, about. So each of those nitrogen atoms weighs 14 grams. You put them together, then the nitrogen that most of our air is made out of weighs about 28 grams per mole. That's per that huge number. So compared to that, if we looked at carbon dioxide, a carbon which weighs 12 grams, an oxygen which weighs 16, plus another oxygen which is another 16. So altogether, that's 44. If that's wrong, I'll edit it out later. So that's 44 grams. So which one's going to sink? Something that weighs 44 grams or something that weighs 28? The 44 is going to be weighed down. So really, we can't tell the exact weight. Our scale isn't fancy enough that we can tell the exact weight of these, but we can tell the relative weights. So a 44 gram set of molecules is going to be denser, so it will sink. So our bags weren't empty on our scale. Our bags were full of air, which is mostly nitrogen. So if it's mostly nitrogen in there, you pour the carbon dioxide, it hits that, and the carbon dioxide sinks down. It pushes the nitrogen out of the way. What we proved with this is that air weighs something. We may not be able to tell that on a scale. We can't measure out, in your kitchen anyway, the exact mass of that carbon dioxide we made, but we saw twice that it's heavier than the rest of the air. If it's heavier than the rest of the air, it has to weigh something. So with that, we're able to prove air has mass. This also relates to a big, huge rule in chemistry called the law of conservation of mass. Conservation just means you're saving something in general. So the idea is whatever you put in has to come out. So we put in a certain amount, a certain weight, a certain mass of carbon and oxygen in our baking soda and our vinegar. When we get that out as carbon dioxide, it still is the same number of atoms and molecules of the carbon and the oxygen. So whatever weight you put in also ended up being the weight that came out of it. So with that, the mass is conserved, and we can actually prove that by saying, hey, this carbon over here weighed something, so does the carbon dioxide on this side.